phase difference between EMF and the current. Last class we discussed about the instantaneous value of alternating, the instantaneous voltage of alternating current is V is equal to Vm sin omega t. Likewise, I is equal to Im sin omega t, where V is the instantaneous value of alternating voltage and I is the instantaneous value of alternating current. When the alternating voltage is applied to a circuit, an alternating current will be produced. How they produce? It will produce immediately, otherwise it will take some time. That is the question. If an alternating voltage is connected, if an alternating voltage is applied to a circuit, it will produce an alternating current, but it takes certain time. It will not produce alternating current instantaneously or immediately. There is a certain time lag between the production of current and application of alternating voltage. That makes some difference. Okay, good. What is the maximum value of alternating voltage here? V equal to Vm sin omega t. In the case of EMF, we use E equal to Em sin omega t, where Em is the maximum value of induced EMF and Im is the maximum value of induced alternating current. These two are two sine waves which represents EMF with respect to time and which represents alternating current with respect to time. Both are sine waves, but there is some difference in the diagram. Before explaining this diagram, I want to tell you an example. What is the example here? There is a train. In the train, the front part is engine. The front is engine, where the driver drives the train. In the last, there is a God. Okay. So when the engine moves, the God follows. Wherever the train goes, wherever the engine goes, the God will also follows in the same path, same way. Because engine drags the God. Okay, so engine is moving in the front and the God is completely following the same way with the same velocity of the engine. Okay, but here this is what engine, this is what God. Now when the engine starts moving, God is also starts moving after certain time interval, because the train is so much length. So when the engine moves, the God also moves. Okay, when the engine goes here, when the engine goes here, then the God reaches where? The God follows the engine and reaches here. Now the engine is moved towards, this is engine, this is God. Now the engine is moving towards west, now the God is moving towards north, but God follows exactly the same way of the engine, but the direction is different here. The second point, when the engine reaches here, the God also follows, but there is a change in the direction here. When the engine goes towards north, the God goes towards west. So here also there is a change in direction, but the path followed is exactly same, the velocity is exactly same. Likewise, third point, when the engine reaches this point, the God follows here. So here the engine goes towards east, the God goes towards west. The direction is different, but God follows the same way of the engine with a constant velocity. Here the engine is EMF and the God is current. So current follows the same way of the applying induced EMF, alternating EMF, but here there is some difference in the direction, here some difference in the pace. Okay, what is the reason for pace differencing? What is the reason behind pace difference? I draw one diagram. This is a diagram for EMF. Okay. This is a diagram for what? Current. Current follows the same way of EMF, but there is a time gap, there is a delay. It starts from here, but the EMF starts from the origin. EMF is nothing but it is an energy provider, which provides energy to the charge carriers. Here the charge carriers got the energy and it gets accelerated. That means current will be produced at this point. The current will start to produce from this point. But the energy is given by the EMF from the origin. The energy is given from the origin, but the current starts producing from this point only. So there is a time delay of transferring the energy. EMF is given the energy, but due to the time delay of energy transformation, there is a phase difference between the current and voltage. Okay, current is nothing but it is a movement of charge carriers. Where the charge carriers are moving, starts are moving from here, but the energy is given from the origin. So there is a delay. This is the delay. This makes the phase difference between the current and voltage. So EMF is a cause, current is a result or effect. There is a time delay between the cause and the effect, or cause and the result. Okay, what happens? Is it good or bad? Okay, we will discuss further. What is the formula for work done? Work done is nothing but the product of force and the displacement is known as work done. Am I correct? Yes. The product of force and the displacement is known as work done. If the force is applied, the object will displace. That is called work done. Okay. If any one of them is 0, then the work done is 0. Here the force provider is nothing but, consider EMF is the force provider, which provides force, for example. So the charge carriers are displaced, the current will be produced. So when both of them are present, there will be power, because the formula for power is product of voltage and current. Here EMF and current. When both of them are present, the power starts in the circuit, otherwise the power will be 0. Okay, here when the power is produced, that means both EMF and current both are are present in the circuit. That is the condition needed. If any one of them is 0, the power will be 0. But in the phase difference, the technical term phase difference between the current and EMF plays a vital role, dangerous role. What is that? The EMF is alternating in nature, that means sinusoidal in nature. So the EMF, consider this is an indicator of EMF. Here the EMF is 0 and then it goes to maximum E0 EM sin omega t, and then it will become 0 and then it goes to negative maximum. So the EMF propagate like a wave. In what manner? 0 maximum, 0 negative maximum. Likewise the current also propagate like this: 0 maximum, 0 negative maximum. Okay, no problem. But when the EMF is applied, when the current is produced, when the EMF is maximum, the current will be 0. The product of these two gives power. What will be the power now? 0 into anything? 0, 0. When the EMF is 0, the current is maximum. What is the total power? The power is the product of EMF and current. Now the power is 0. Once again, the current is 0, EMF becomes negative maximum. Whatever it may be, when the product of anything with 0, the result is 0. So the power is 0. So there is no power in the circuit because of the phase difference between the current and the EMF. So it plays a vital role. This phase difference plays a vital role. Okay. What is the cause of this phase difference? what is the cause of the engine and God, the direction change in engine and the God? Because the cause for the different of direction between the engine and the God is length of the train. Here also there is a resistance between the current and the EMF. So only the energy of the EMF will not immediately transfer to the current. There is a resistance. Which provides resistance? It may be a capacitor, it may be inductor, it may be a resistor, which we will discuss in the further classes. Okay. Due to this resistance, there is a lag or lead in the current and voltage. There is some lag or lead between them that makes the phase difference between them. So what are the ways to represent the phase difference between the current and voltage? There is a phase difference between the current and voltage. We know, okay, how to represent, how to depict the current and voltage. There are two ways of representing. One way is wave diagram. This is what wave diagram. This is nothing but it is easier to understand. In the above diagram, in the given diagram, a graph is drawn between EMF and the time. Here a graph is drawn between the current and the time. Okay. When the EMF starts, that means the EMF starts from zero origin. The current starts from zero here. It is not origin. It is where? Pi by 2. The dotted lines represents here. It is pi by 2, here 0. The pi by 2 of EMF is equal to the 0 of current, 0th position of current. So what is the phase difference between 2? Pi by 2 minus 0 equal to pi by 2. The phase difference between the current and the voltage here is pi by 2. We go to the next step. When the EMF completes one cycle, the current completes only half a cycle, but the current follows exactly the same way of EMF with constant velocity. It exactly follows. It strictly follows. But only is time lag. This makes the phase difference between them. Okay, right. We can measure any point between these two diagrams and to find out the phase difference. If we can measure at this point, this is pi by 2, this is pi, then this point is 3 pi by 2, this is 2 pi, and goes on. So for example, this is 3 pi by 2, this is 3 pi by 2 for EMF, then what is the value of here? This is 0, then this is pi by 2, so this is pi. What is the phase difference between these 2 points? 3 pi by 2 minus pi, how much? 5 pi by 2 minus, what is this? 3 pi minus 2 pi by 2. Yeah, 3 pi minus 2 pi, pi by 2. So here also the phase difference is pi by 2. Yes, you can measure anywhere between the two graphs. Anywhere, here, 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 anywhere you measure, it gives phase difference is pi by 2 because there is a constant phase difference between the current and voltage. Here the voltage leads the current by the phase angle pi by 2, or the current lags behind the voltage by the phase angle pi by 2. You can measure anywhere. So the phase difference here is constant phase difference, which is equal to pi by 2, but it doesn't mean that the phase difference between current and EMF is always pi by 2. It is not always pi by 2. Here it is pi by 2. In other cases, it may be the constant phase difference between current and EMF may be pi, or may be 0 degree, or may be pi by 2. Anything. Here only pi by 2. It is not always pi by 2. In this case, it is pi by 2. In different case, it may be a pi. Okay? Okay. Okay, this is about the phase difference between the current and EMF. What we learned in this class? What is the phase difference between current and EMF? What is the meaning of phase difference? Why the phase difference takes place? Okay, what is the cause of phase difference? Power becomes 0. Okay, then who produced this phase difference? In which circuit? It may be a capacitor or inductor or resistor. Okay, these things are discussed here. So you go through this, it will be very useful for you. Last one thing, the phase difference between the current and voltage or EMF can be represented in two ways. One is wave diagram. This is nothing but wave diagram. The another one is phasor diagram. That is most important thing that we will going to discuss in the next class. So don't miss it. Please watch the video and make notes from this video. This is very useful for you. Till that, thank you my dear students. Thank you. Bye.